Hey, what's up, everybody? We're on Module 7, Lesson 8. This is our last module, or our last lesson in this module, and it is all about writing and solving multi-step, or in this case, just two-step inequalities, which is, again, compared to the challenging multi-step solving of equations you've done, this really is not that difficult. You've done way more difficult than this. I would say the hardest is probably writing and solving the word problems. All right, so let's go through. Remember, when you have multiple steps with variables, you must use SADMERG, opposite order of operations, to solve for a variable. Okay, so we're going to go through that step together. Also, as we go, remember, when you multiply or divide by a negative, you must change the sign. Do I need to do it again, or will you remember that? Click the box if you want to play it again. You can listen to it over and over again. All right, so let's go ahead and walk through this. We need to do a rewrite, or you can just lasso paste this down here, and let's go ahead and solve this one together. Always separate your workspace. This is an organizational thing. Okay. Remember, SADMERG says take care of any addition subtraction first. Okay. And so in that case, we're going to add 12 to both sides. Okay. After doing that, that goes away, and we have negative 5x is less than or equal to 20. Okay. All right. Now, we didn't multiply or divide by a negative. Just because you see a negative doesn't mean that you change the sign. Okay. Only if you multiply or divide by a negative. So now we're at this point where we need to isolate the variable. So we're going to divide by negative 5. When you multiply or divide by a negative, you must change the sign. So there we go. We're changing the sign right away. And we have x is greater than or equal to the 20 divided by 5, which is 4, but it's positive divided by negative, so we have a negative. Okay. All right, let's go ahead and I do want you to see this. I haven't had you doing this very much, but it says check your solution. And that means just make sure that what you got works within the inequality. Reminder that we're calling it an inequality because it's not exactly equal to. It's going to be a less than or greater than scenario. So we're saying all the x's that are greater than or equal to negative 4 will work in this equation. So let's just pick something nice and easy. We have... maybe I'll do a negative 10. That's greater than negative, or actually greater than or equal to negative 4. Something greater that would be really easy is 0, right? 0 is greater than negative 4. So 5 times 0 is 0. 0 minus 12 is a negative 12. And negative 12 is definitely less than or equal to 8. So we've proved that that's true. That's what the checking would be. Let's go ahead and graph your solution. We draw a line. Remember, there's our steps if you need them. Draw a line. Make your 3 ticks. Tick, tick, tick. Write your target number, negative 4. Write one number bigger, which is negative 3. One number smaller, which is negative 5. Now we look, is it closed or open circle? I see the cement. It's just a trick. We're saying is equal to means fill in the circle. And then we read from the variable. Notice I put it in here now, so you don't have to write it. Read from the variable, we have x is greater than, because when I read from the variable, I see the greater than side of that first. So we go to the right, and there we go. Okay. All right, let's go ahead and try out the check. Okay, if you want to pause and try, you can, or follow along. Remember, when we're doing opposite order of operations, we're doing SADMERG. Okay, so we take care of any addition subtraction first, the simplest first. So add 4 to both sides. That crosses out. We have a negative 6x is greater than 18. Now we can go ahead and isolate the variable. So we have an x times a negative 6. We would divide negative 6 on both sides. That crosses out. And we have, when you multiply or divide by a negative, you must change the sign. So we change the sign. We don't want to forget that. 18 divided by 6. Let's go ahead and do that on the calculator. 18 divided by 6. And you get 3, but it is negative, okay, because we have 18 divided by negative 6. All right, let's go ahead and graph the solution set. Remember, it's a set because it's a whole bunch of numbers that work. Make your line, make your 3 ticks, tick, tick, tick. Write your target number, which is negative 3, one smaller and one bigger. Okay. Do you have a closed or open circle? Is there any cement? Nope. So we're doing an open circle right on the line, not above it. Okay, and then we read from the variable. So x is, I hit the less than side. X is less than, which means go to the left. Okay, and there we go. We're good. All right, let's go ahead and take a look at example 2. Same thing, we just have decimals. Let's go ahead and lasso this down to the bottom. And here we go. Time to solve. Separate our workspace. SADMERG tells us to take care of addition subtraction first, so it looks like we're doing the same thing every single time. Pretty repetitive. They're not making these difficult to solve for sure. All right, so what do we have left? We have 4.7x. We didn't multiply or divide by a negative yet, so that stays the same. And then we have 10.85 plus 3.25, and that gets us 14.1. Okay. All right, so let's go ahead now and isolate the variable. Instead of times 4.7, we divide by 4.7. I'm not multiplying or dividing by a negative, so no sign is changing. And we're left with x is less than or equal to whatever that is. So I'm going to go ahead and enter, and then all I have to do is put answer and then divide it by 4.7. Okay, and we get a positive 3. Yep. All right, so let's go ahead and graph our solution set. Draw our line, make our 3 ticks, tick, tick, tick. We have a 3. One bigger is 4, one smaller is 2. Closed or open circle. What do you think? Yep, see that cement there? Closed circle. All right, we read from the variable. X is less than, so it goes to the left. Make it stand out, and there we go. Okay. All right, and that means any x that is less than or equal to 3 will be true for this inequality. Okay. All right, let's go to the check here. Separate your workspace. Good one for you to pause and try out, and then you can sort of speed up and check and see if you did it correctly. All right, opposite order of operations. SADMERG says to take care of addition subtraction first. And so I end up with a 1.3x is greater than or equal to, let's see, 4, 5, 6, 7.8. Okay, now we're going to go ahead and get rid of the times 1.3 by dividing by 1.3. And we end up with x, multiply or divide by a negative. Nope, I didn't do that. Stays the same. All right, so 7.8 divided by 1.3, and we get 6. Okay, let's go ahead and graph our solution set, make our line, our ticks, tick, tick, tick. Put our target number, one bigger, one smaller. Go ahead, is it a closed or open circle? It is closed because it is equal to, I see the cement there, and we read from the variable. X is greater than, so an arrow to the right. Okay, so there we go. All right, let's go ahead and check example 3. Okay, go ahead and rewrite or lasso. I'm definitely going to lasso that. Okay, same thing, just with fractions. No big deal. You know how to do this. You can also use Desmos if you want. Okay, separate our workspace. Let's see, I could change all these to decimals too, but it's really not too big of a deal. I have to add a half. I am going to change that to 4/8 so that I can take care of this work. So that's just a recommendation there. Or change it all to decimals. Up to you, really. All right, so let's add 4/8. Add 4/8. That all goes away, and we're left with 3/4. 3/4 x is greater than 4, 5, 6, 7 eighths. Okay, then we can go ahead and get rid of that times 3/4 by dividing by 3/4. But remember, we don't divide by fractions. Instead, we multiply by the reciprocal. So multiplying by 4/3, this whole thing cancels out. We didn't multiply or divide by a negative, so x is still greater than, and then we can cross simplify this a little bit here. So divide by 4 is 1, divided by 4 is 2, and we're left with 7/6. Okay, and so there we go. So this is good for you to see how to graph something like this. We have 7/6, and let's go ahead and draw our line. And I'll show you, it's actually like not very complicated to take care of on a number line. Tick, tick, tick. We write our 7/6, and look how simple this is. One bigger, you just say 8/6. One smaller, you just say 6/6, or one whole. Okay, so you don't have to make it complicated or do anything fancy there. All right, so x, read from the variable. We have x is greater than. Do we have a closed or open circle? I don't see any cement, so it has to be actually greater than, so not including that. X is greater than, so we're going to the right. Okay, so there we go. All right, let's go ahead and do your check here. Good one for you to pause and try. Go ahead and hit play then and see how you do. Okay, with this one, same thing as before. We're going to take care of any addition subtraction first. So plus 5/6 plus 5/6. Since it's out of 6 and I'm adding it, I can pretend that this is 3/6 instead of 1/2. Okay, makes it easy for adding up. This crosses out, and we have 2/3 x is less than 8/6. Okay, all right, now we can go ahead and isolate the variable, get rid of this times 2/3 by dividing 2/3. But remember, we don't divide fractions, right? We multiply by the reciprocal. Multiply by the reciprocal. That goes away, and we are left with x is less than. We didn't multiply or divide by a negative. Let's go ahead and cross simplify. Divide by 3. We have 1, and we have 2. Divide by 2's, and we have 4 and 1. So there we go. We can multiply straight across. We get 4 times 1 is 4. 2 times 1 is 2. So 4/2. You could change it to 2 wholes, but you really don't have to. It's up to you. If you think you're going to mess that up, trying to change it from improper to mixed number or into the holes, then don't worry about it. You just follow the same routine. So write the target number, 4/2. Write one bigger, which would be 5/2. Write one smaller, which would be 3/2. And you just do your stuff, and it still works. All right, so cement or no cement? No cement, open circle. Read from the variable. X is less than, so we go to the left, and there you go, all done. So you could plug in anything that is less than 4/2, and the statement will be true. Okay, so that's how you handle that. Of course, you could put those into decimal form as well. Let's go ahead and get into your word problems now. Okay, same kind of thing. I guess I really want you to just see the patterns that exist and just trust yourself that you're going to keep seeing these patterns and to trust your brain with these patterns, but you still do have to use some common sense and think about what's going on. So let's take a look at this problem. Halfway through the bowling season, Stuart has 34 strikes. So I'm thinking it's sort of like so far he has 34, okay? He averages 2 strikes per game. Again, per a lot of times means multiply. 2 strikes per game. I'm guessing G could be game, right? All right, he needs, here's my inequality phrase, at least 61 strikes. So we have to think about what at least means. We could look over there, but I really want you to be thinking without that now. So at least, okay? So he wants 61 or more. So he wants greater than or equal to 61. Okay, that would be at least. Because is he okay with 61? Yes. All right, so you found sort of like the final side, which is right there. So that's important. I always keep telling you, find that. then deal with the other expression stuff. Okay, so the question says, write and solve an inequality to determine the possible number of games. Okay, so G is going to be our variable like we thought, to get at least 61 strikes. And we already circled all that, so we don't have to worry about it. Okay, so down here, okay, you can see they already did it, but whatever. Okay, so at least 61 strikes. And now let's take a look up here. It says he already has 34 so far, okay? And he does about 2 strikes per game. So he already does 34 plus 2 per game. And we want to know, in that situation of the 34 plus 2 per game, how many games to get at least 61. Okay, and you can think about it as an equal sign, even though it's not. All right, let's go ahead and solve for G and see what we get. All right, so what do we do first? You have to take care of addition, subtraction, okay? And we're not going to move this whole 2G over there. That doesn't make sense. We want to get the G's on one side, numbers on the other, okay? So I have a positive 34, so I'm going to subtract 34 on both sides, okay? So just be aware of what that 34 really is. This cancels out, and we're left with 2G. Did we multiply or divide by a negative? Nope, we just subtracted. Less than or equal to 61 minus 34, and we get 27. Okay. All right, now we can go ahead and isolate the variable. We have 2 times G, so I want to divide by 2. Divide by 2. I'm not multiplying or dividing by a negative, so that crosses out, and we are left with G is greater than or equal to 27 divided by 2 is 13.5. Okay, so this is games. Okay, and so as we do this, okay, we have, I just wanted to make sure that 61 minus 34, yeah, it's 27. Okay, it's just weird that it's a 13 and a half games, but I mean, it's at least, so whatever. All right, let's go ahead and answer the question. So how many games does he have to bowl? How many additional games should he bowl to have at least that? He should bowl, and then I'm going to change colors here to really emphasize this. Look, at least. You have to use that phrase. At least. If you don't, you lose a point, because it's not he should bowl 13.5. It's at least 13.5. Okay? So that's what has to happen, is at least 13.5 or more in order to meet the goal of that many total strikes. Okay, so it might happen mid-game based on all that. All right, let's go ahead and try it here. If you want to pause and try it out on your own, see if you can figure it out, then you can check. It's always good practice. So Peter can spend, oh, look at that, no more than. Okay, what is no more? So $100 or less, no more. So less than. Can he spend 100? Yes, because it says no more than that. So less than or equal to. So I figured out my answer spot, right? So that's where I write that right away. Now I just have to figure out my other expression stuff. So he spends $35 on a new pair of shoes. Okay, spending usually means subtracting, so let's see if that plays out with this. So spends $35 on a new pair of shoes. Shirts cost $15. How many shirts can he wear? So the shirts would be like an S, how many shirts? So we're adding up the total spending though. So we're not actually subtracting, okay, even though it says the word spend. That's why the context matters. But so let's see. So he already does the 35. That's something that's already happened. And then something else has happened, right? So we're adding other spending. Well, what is the spending? Well, $15 shirts, but the question is how many shirts? That's where we get the times S for how many shirts, okay? And all that spending must be less than or equal to, or no more than $100. So that's your expression that you had to figure out, or your inequality you had to figure out. Let's go ahead and solve. Okay, so where is the addition subtraction? It's right here. I have a positive 35. We're going to subtract 35 to both sides. Okay, that goes away, and we have 15s is less than or equal to. We didn't multiply or divide by a negative. Okay, 100 minus 35, doing a calculator to just be sure, is 65. Now we can isolate the variable, right? We have s times 15, so let's divide 15 on both sides. That crosses out, and we can purchase, let's see how many shirts. Okay, 65 divided by 15. Oh, I can do answer divided by 15. All right. So let's see how many shirts. It says 4.33. So 13 thirds, or 4 and 1/3. Okay. So let's go ahead and sort of see how this works here. Okay, so we have 4.3 repeating, okay, amount of shirts, okay. So really, I mean, can you do 0.3 repeating of shirts? Not really. So let's really interpret this in a good way here. So let's go ahead and think through this. So how many shirts can Peter purchase? Okay. Well, he can technically purchase no more than 4.3 shirts. But since we can't really do 0.3 shirts, the answer is just no more than 4 shirts. Okay. So you have to think of the context of the situation. So Peter can purchase no more than, we have to use that phrase from above right there, no more than 4, because we're not going to do 4.3, that doesn't make sense. No more than 4 shirts. So you got to have a little bit of common sense with what's going on. Okay. All right. And that'll be the true situation there. All right, let's go ahead and do these ones. We have a little bit different of anything you don't finish is homework. So let's go ahead and do a couple together. Why don't we do, let me see if we have, okay, let's go ahead. I want to leave number 1 to you. Maybe you can figure out why. Let's go ahead and do one of the, I think we just do number 6 together. And then the rest of them you can try on your own here. So let's go ahead to 6 and solve this out. You may not have all the space you want. I wish they put this a little bit higher. If you want with these, you could always lasso them and just paste it up a little bit higher to do the work, and that would be fine. So maybe do that. All right, so let's sort of think about what's going on here. We're doing SAD-MERG, okay, opposite order of operations. So I have to subtract 1/4 to both sides, okay? The problem with this is we have to make common denominators to add or subtract fractions. So the other thing you might want to do is just change these to decimals. So since we didn't do that in the notes, let's go ahead and do that one for this. So I'm going to actually go ahead and remove this, okay? And we're going to rewrite this using decimals instead. So x divided by 10 plus 0.25 is 1/4 is greater than or equal to, and remember 1/5, do you remember that from your fraction decimal chart, is 0.2, okay? So now we can go ahead through this and just treat everything as decimals. We subtract 0.25, subtract 0.25. Let's go ahead and write what's left over. So we have x divided by 10 is greater than or equal to 0.2 and negative 0.25. So if you add on a 0 here, a placeholder, you can see 0.25 is going to pretend to be our bigger number here. even though it's a negative. So different sign subtract. So we're doing 0.25, boop, 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 0.25 minus 0.2, and we get 0.05. Okay, so and it's negative 0.05. Okay, so different sign subtract. All right, now we can go ahead and solve for x. So instead of x divided by 10, we're multiplying by 10 on both sides. Okay, we're not multiplying by a negative, so everything stays. So x is greater than or equal to. When we're multiplying by 10, we move it a decimal point to the right. Okay, and so we have negative 0.5. Okay, or negative 1/2. Okay, so let's go ahead and graph it now. So where is negative half? Well, negative half is here. So we're going to make a big tick mark and write negative 0.5. Okay, and then we can go ahead and graph the rest. Okay, so I'm going to go ahead and look. Is it closed or open? Well, I see cement, so it's closed. We do it right on the number line. And then we read from the x. Okay, so x is greater than, so we go to the right. And there you go. So that's the process you're going to follow. You can do the same thing for number 5 or just work it out as fractions. It's up to you. But definitely you're not going to have enough room to solve them where they are, so you're going to have to go ahead and move those up by either rewriting or move them with the lasso. All right, let's go ahead and do a couple of the word problems together. I'll leave 7 and 9 for you. Let's go ahead and take a peek at 8 and 10 and at least get them set up. Okay, so Matilda needs at least, oh, I found my word already, so we're looking for these patterns, right? At least 112. Okay, so what does at least mean? Okay, if you saved this in your camera roll from before, then, oh, not that one. Let's go back. Where's my notes here? Maybe we want to do that with this one too. That might be a good screenshotter to keep in there. So I'm going to screenshot that, put it in there. There we go. Done. Save the photos, and there we go. Now I have it. If I want to bring it in here, I don't want you. Go away. But I do want you. Thank you. Hello, you. So I'm going to put this right here. Okay, so if I want to take a peek at that, at least we can see is greater than or equal to. Okay, but you should be able to think through those a little bit on your own now. Okay, so I've always told you if you know what the answer side is, do that now. So at least greater than or equal to 112. Okay, now what's the expression around everything else? Let's see. She already saved $40. And she earns $19 an hour. That's like per hour multiplication. It's pretty much been the same every time. Okay, per hour, like times H, right? $9 an hour. Write an inequality to determine how many hours she needs to babysit to buy the dress. So she needs to earn this total of 112. Okay, but we're saying at least. All right, so she's already saved 40, right? Plus, she's going to work $9 an hour. So there you go. So go ahead and solve that and then answer the question. Okay. All right, let's practice the word problems again with number 10. So this person, Robin, was given a $40 allowance. So that just happened. Here's $40. She wants to go to the movies as many times as possible. So movies is probably going to be our variable. But she wants to have, this is the result, right? The total on the far right. She wants to have at least $12.50 left at the end. So right away I know, okay, at least, okay, so she wants $12.50 or more, okay? So that's greater than or equal to $12.50. That's sort of like the answer side, okay? All right, so that's my first tip to you. A movie ticket is $5. Okay, we want to know how many movies. So it's like 5 times M, right? $5 per movie. Even though it doesn't say per, you have to sort of notice that. Okay. Okay, so ready? Here we go. So we started with $40, right? What happens to that $40 as we keep going to the movies? Are we adding money? to our $40 or losing it? So that's what you have to think about, what's happening. And I'm losing $5 per movie. So then we can go ahead and solve and figure out how many movies we can go to. But really practice trying to interpret that accurately. Okay, you don't have to graph these. We're just solving and answering the question. All right, so your job with 7 and 9 is to see if you can figure out how to write the equations, but please look and imitate what we just did and those patterns that we talked about. Okay, all right, go ahead and work on this for your homework as practice, and then we can go over it together.